Well, it's Easter Sunday and not much going on. I've been out and about this morning, went for a walk down the beach and come home, had a cup of tea, had a bit of lunch, and it's now time for a little bit of relaxation and silliness, really. Silliness? Well, I've got another little kit from Banggoodd, and this one is actually a torch, or for our American cousins, a flashlight. And this costs £1.26. What's that? £1? Well, $1.70, something like that. Shipped. Not much money at all. And it is, as I say, a flashlight. And as you can see here, we have a little board which has on it a space marked out for an LED, a 47 microhenry inductor. That looks like a transistor, but a little bit of research tells me that that is in fact not a transistor but an LED driver, which kind of makes sense. And I have to be honest, I have cheated and looked around, and the device is powered by a AAA cell, ordinary AAA cell, but because the LED needs 3 volts and the AAA cell only provides 1.5, then the electronic wizardry, which I don't understand, of course, provides 3 volt pulses, and that allows the LED to illuminate. So there you go, clever stuff. That's a location for a switch. Underneath we have 2 large pads there and there, and they will be connectors for the AAA battery. So let's look at those components. In this little bag. Open that up. And we have a plastic red button for the switch. Speaking of which, and that is the switch. On, off, simple as that. We have 2 battery terminals for the AAA cell. We have an almighty great LED, so that's like 6 to 8 millimeters, something like that, quite big. White LED, as I understand. The LED driver, which looks like a transistor, and that is get the old magnifying glass out. That is, I don't know if you can read that. Can you read that? A YX8115. And as I say, I understand that to be an LED driver. We have some resistors. We've actually got 4 resistors, but the board only has facility for 1. And the reason for that, I think, is because you can, that will be current limiting, I think, for the LED, and therefore you can decide whether how much brightness you want the LED to have. There's no instructions with this kit, although there are photographs of the completed item on the Banggoodd webpage, so you can see the finished construction of it. But I'm just going to put my meter here, and let's have a quick look at what the value of these resistors are. So we've got these. Let's see what that one is. Let's bring that down to ohms. That's 22 ohms, let's say. And this one is 47 ohms. So I'm guessing if I put in 22 ohm, it's going to be brighter. So we use a 22. But I'm also guessing if I use a 22 ohm, it's going to eat the battery that much faster. We'll see. I might even test to see how long the battery lasts. That might be interesting. Put in a brand new battery, just leave it switched on, see what happens. There we go. Right, so that's the resistor. The other thing to bear in mind with this kit is that the LED and the switch I'm looking at LED. I don't know if I can focus on it here. Can I focus on that? Was that too much? I'm sorry, it's wobbling around. It's got, there you go. That LED ain't fitting in to the case unless you're supposed to put it in only a little bit. But then that would make, well, I suppose you could put it in that way. I think it's supposed to only pop out a little bit. So you'd only want the LED. The LED is kind of just poking through the hole by the looks of things. I'm going in and out of focus here, I know that. Apologies. But yeah, I think that's kind of the idea, that only a little bit shows through, which yeah, I don't know whether I want it to be like that or whether I want more of it to show through. I really don't know. Would it make any difference if I have it? If I have more of it showing through, I'm going to get better illumination, because presumably if I've got all of this part of the LED inside the case, then one assumes you're losing an awful lot of illumination into the case, and the light output would be that much less. I don't know, but certainly it doesn't fit. There you can see there's a gap, in which case it's not going to fit the other side of the case. Because I've got the right side of it, of course. Because there's two cutouts, one for the switch. Let's have a look at the switch. Well, actually, I think it won't actually be the switch itself. It'll be the red button. And that fits in there very neatly. That's all right. And the other thing to bear in mind when putting this together is that underneath that pad, underneath that board, you've got these connectors here. You can see they're all common there and there, and that's where you're going to stick the battery terminals. So obviously they're going to raise off the ground a little bit. I think what I'm going to do is I'm going to make the board up, and then I'm going to modify the case to fit rather than the other way round. Yeah, I think that's what I shall do. So I think the first thing to do, I've already decided I want to use this resistor. So let's focus on the bench, and we'll start soldering a few components on. Now, I have to say, it does seem, unless I'm missing a trick somewhere, and of course I haven't seen how bright this LED is, or whether it's, you know, super magical in terms of brightness. which I'm suspecting it won't be. But in case it is, it does seem awfully over-engineered just for what is effectively no more than a torch come flashlight. On the other hand, it's a bit of fun, and we do like a bit of fun, it has to be said, when it comes to building these kits. So, armed with a trusty piece of solder, let's get this resistor put in there. I'm guessing, as I say, this resistor will actually mean that the battery is likely to be eaten up that much quicker. But like how much, I have no idea. I mean, even if it just lasts an hour, you know, a torch like this, you're not going to be running it constantly. It's just going to be a convenience item that you can stick in the car or by your bed, or as a inspection tool for something. I don't know. Whatever use you have for flashlights. Let's stick the what I think is an LED driver, which looks like a transistor. And I'll push that down as much as I possibly can, because that'll do, I think. I mean, there's a fair bit of depth in that case, so I think components sticking out that far will be fine. So let's solder that into place. Toss that around so I can see what I'm doing. Alright, let's have a look at the quality of that soldering. Yeah, it'll do. Not bad for me. So, do you know, one of the things I have got to buy is a decent pair of snips. These things are absolutely bloody useless. And I don't know what makes for a good pair of snips and what makes for a bad pair. Apart from, I guess, the cheaper you go, the worse they're going to be. Yeah. Right. Inductor. Shall I do the inductor next? There's my little nose point pliers. So I kind of want to bend them about there, I'd say. So there you go. And let's have a look at how good that is. I probably should have bent it a little bit closer. I'm careful I don't actually... You can't see anything, can you? There you go. So I'm trying to look through the camera and do this at the same time, and that won't work. Let's try that. It's a bit better. Let's just bend those legs out a bit. No innuendo, stop making up your own jokes. There we go, that's about right. Dab of solder. This damn thing works afterwards. Should do. I mean, there's very, very little to it. You're off camera again, aren't you? I really haven't got this camera set up properly at all. I was using the GoPro on some of my earlier vids, which is a lot easier to use, but the quality of the video up close is poor. Obviously, a GoPro is not really designed for this sort of work, and what I've got here is an iPad mini suspended up in the air, which is not good. Good enough for filming, but it's a very difficult thing to keep in position. And of course, although it's a mini and not full-blown iPad, it's still quite a large device when you've got it right in front of your eyes and you're trying to do something. Right, so that's those components. Now the next thing to do is to try and work out the best way of, I'm just thinking actually whether it would be better to install the battery connectors, because they need to be installed underneath. I guess they need to stick out a little bit like that, I would say. Yeah. So what I'm going to do is I'm going to use one of the crocodile clips from my oscilloscope oscilloscope probes. The idea being, what I can do, now let's just work this out. Yeah, that one needs to be minus, and it needs to be about there. That's where the pin needs to go. So if I hold that with the crocodile clip, around about there. Oh, it's already moved. Don't think a crocodile clip is actually the best thing for this. Oh, it isn't. I'm going to have to rethink. Unless I can do it by hand. No, I think that will screw things up. Let me see if I can find. This is a bit. It's probably a bit too big for what I want. This is fiddly. My God, this is fiddly. There must be an easier way of doing it than this. There's got to be. I don't think this is going to work. I know I'm going off camera all the time. I do apologise. No, that's not going to work. Right, what I'm going to do is I'm going to pop a bit of solder on the end there, like that, and then I'm going to eyeball it. So just to try and get it held in place. I'm wondering if that's too close to the board for the battery to fit in there comfortably. I think it is. So let's try. Let's try putting a bit more solder on the end there. Solder doesn't dry as quickly as you'd like it to sometimes. This is a complete bugger's muddle. Hang on a minute. Nope. Where's my tweezers? Alright, come on, stop laughing at me. I know you are. I would. Oh, come on, you swine. Right, let's have just a quick look at that. So what I want to do is I just want to offer it up to the board and see how much clearance we've got here. So, oh, and it's fallen out again, would you believe it? Interestingly enough, I probably do need to cover all 3 pads. Now I've dropped the bloody thing. Oh, this is fiddly. I'm not liking this. I know what you use. Yeah, I thought I had a bit of blue tack kicking about, but if I have, it's disappeared. And that would have held it in place quite neatly. I'm sure I had some. But there we go. I obviously haven't. So, what I'm going to do, at the risk of burning myself, which is more than likely, let's rest it on that. How's that going to work? Well, I suppose I could always bend it up a bit once I've got it properly soldered in. But it's nice and level onto the board, so I'm not tempted not to lose that. So let's see if we can solder it a bit more without it being lost. No, I'm sorry, you missed that. But there we go. I would say that was well and truly trapped in there, and what I can do now is just bend that up a bit. But I'm not convinced. You see, the trouble is that when you stick it in the box, is a AAA battery going to sit in there? As you probably will do, because AAA is going to get one. Right, one AAA battery. Is that AAA? I've got the right one, haven't I? Yeah, AAA. So that will be the negative down that end. Yeah, that'll fit. Yeah, that's fine. That should fit. It's going to be tight against that. It's going to be tight against that switch. That switch has got to go in there. I'm not entirely sure how that works because it's got 6 pins, but I'm guessing I only need 3 of them. Would be my guess. I think we'll have to go and check that in a minute. I can't believe we're 25 minutes into this. Good God. I'm so sorry if you're bored. Right. If you're not, I would be. But it's nice to have a chat, isn't it? And do these things. So how's this one going to go? This one's going to go like that. Right. So same procedure again. A blob of solder. And then, armed with my tweezers, that needs to well, that doesn't quite work because that needs to go like that, doesn't it? Like that? Yeah, like that. We hold the tweezers that way. Can you see? Not just about. Right, again, so it's not straight or anything, but once I get the rest of it soldered up, it'll be nice and strong, and I'll just bend it into position. Now, how does that line up with that one? Not brilliantly. Will it fit in the case? Just about. That's not right, is it? That's the wrong way up. Idiot. It needs to be that way, but yet the conical shape of the battery holder, have I got that on the wrong one? No, that's minus. You wouldn't have thought something like this would be so flaming difficult, would you? That's minus. But you can see what I'm saying is that that needs to be that way round. So the top of the cone is this side. See if that'll focus. Which means it would need to be that way. But if you look at it, it really should be that way. But the cone is pointing in the wrong direction. So that doesn't work, because that's the negative end, and that is correct. That needs to be the positive end. It needs to be like that, but it ain't going to work that way, because you can see there, that's not going to work at all. I need to think this through. Well, I went back to the Banggoodd website and just to have a look at the photographs of how they've done it, and they have actually done it like this, with the conical shape outwards rather than inwards, which I would have thought would have been better for the battery. But at the end, I suppose it's going to connect okay. Just seems a bit odd. But there you go. That's how they've done it. So I've soldered it that way. So we've got a reasonably good solder joint there. There's a bit of the pin sticking out at the end there. Shall I try and just fix that with a bit of extra solder? Probably doesn't need it, but let's make it as strong as possible, because that is going to be under pressure because of the fact that it's going to be sprung against the battery. So let's make it as strong as possible. Like a right meal of this, aren't I? There we go. Right, I think that's okay. Yeah, that'll do. Right, so that's the battery holders in. Next thing I think we will put in is the switch, but I'm conscious of the fact that we need to offer up the switch and the LED because they're poking out at each end. We've got to make sure that respectively they sit neatly, so those, in fact what I probably need to do is I just put the cap on the switch. There we go. Oop. There. Right. So that needs to sit like that. So if I hold the switch close to the board, is it going to scrape against the side of the case? Doesn't seem to, but what I do see is I need to get the pins. You just use one set of 3 pins, I don't think it matters which, through those 3 holes there. And I think I need the switch just a tiny little bit off the board, so the switch has got a little bit of room to move. So with that in mind, I am going to use my little pliers here to bend, well, let me bend these pins at 90 degrees to the board, and then just try and get them nice and even. And I'll show you what I've done in a second. Let's just even them up a bit. Okay, so you can see I've just bent the pins pretty much 90 degrees. They're not quite level. Let's level those up a little bit, and then offer them up to the board like that, and they go in quite tight, so that's good, because then I can just lift them just slightly up. I think there's a tiny gap there, and that should be sufficient to allow enough play in the case when the button is through the case. So let's solder let's solder the centre pin. I won't solder the others because there is another little thing that you need to do with this switch, and that is to support it. We'll look at that in a second. So that's the centre pin held in place. You can see you've got slight play there, and now we've got a bit of a gap. Have I got this around the right way? Does it really matter? Are those holes the same? I think those holes are pretty much the same. So there's plenty of room. I know it's bouncing about a bit there, but we'll fix that in a minute. So what I need to do now is just snap the case together. Do you know, I don't think there's any harm in that switch being level with the board. I don't think that matters at all. So what I'm going to do is I'm going to solder that flat against the board instead, like that, because apart from anything else, and just straighten her up a bit and a bit more. So this is why you only solder one pin, so that you can manipulate the component until it's in the position that you want, which obviously if I'd done with all three wouldn't have been possible. So that pin, that switch straight. It isn't quite straight, is it? I would say it is now. Right, so let's solder the other two pins. As I say, I'm going to have to work on positioning this camera because it is just not good. Tiny amounts of solder, very, very small amounts of solder. I think that will do it. And now you can see that the actual switch is still loose. So what we need to do is that we need to get a piece of wire, wrap it round the switch, and then solder it through these two holes, so you get it like a loop of wire. So what I need to do is find a piece of strong wire, because they haven't supplied anything, and I don't think the cut-offs from, well, actually a cut-off from that might be long enough. Shall I use that? So let's nick that leg off a resistor that I'm not using, and then bend it to 90 degrees. I might have not done that enough from that side, haven't I? Rats. I don't think that's going to be long enough anyway. I'm going to go and find a better bit of wire. Right, I've got some copper wire here, a bit of, I don't know what the SWG on that is. 20, I think, 20 SWG possibly. Don't know. But it's a piece of copper wire which may be sufficient. So if I take a piece of that, I'll probably need to I need to scrape it. I'll probably burn it off with the soldering iron. But I need to put a piece through there. And solder that on. And the idea is it will wrap around the switch and hold it firmly in place. So let's see if that will work. Is that going to solder? I'm not so sure this stuff will solder. So look, no. That is not taking solder. Let's find something else. Right, what I decided to do in the end was indeed use that leg off this resistor, and it was just about long enough for me to wrap round that switch nice and tightly. So now that switch does not move at all. You can see the band of resistor leg around it, which is actually slightly skew-iff, but that doesn't matter. It's really tight, so that switch is now not moving at all. So that's fine, and that sits nice and flush against the board, and we're good to go. So the final stage is the LED. And the LED, as you can see, has got a long leg and a short leg. The long leg is positive, the short leg is negative. And on this board, the long leg will go through the pin at the bottom, and the top pin at the top is negative, like that. Now, we're kind of back to making judgments as to whereabouts this will fit in the board. We know that if we take out the LED just for a minute, stick the board in the case, and now we need to offer up the LED, and I'll come back to this point again about, do I want it sticking out the case, in which case I'm going to have to modify the case to get it to fit through, or do I want it just poking through like that, which is kind of the way I think they do it, but I'm do you know what, I'm tempted to do it like that. So you've got more of the LED showing through the case, and my theory therefore is you get more light showing through, or shining through. So if I hold around about there, I'm just eyeballing this, and then bend the pins to roughly 90 degrees. Like that. And let's just pop those in. And I think that'll be about right in terms of how far it sticks out of the case. I think that's fine. I'm going to go with that. The other thing is, do I need to bring it that far off the ground? I don't think I do. Okay, so what I'm going to do, I'm going to solder up one of the LED pins. In fact, I'm going to solder up that pin there, like that. And then I'm going to need to cut those legs off, aren't I? So just do that. Leave enough for that one sticking through to solder. And now, hopefully, I haven't committed myself. I think that's about right. That's about right. And once I've cut away more of that, in fact, I think, let me cut away some of this so I can get the LEDs fit nice and flush in there. It doesn't need to come down too far, because I've got to bear in mind I've got the top part of the case, which is not as deep. So you can see that the cutout on this bottom part is obviously bigger than the top part, because you've got the sides for it to clip against. So when it is actually closed, you've got a relatively small aperture for that LED to poke through. So I'm going to have to get slightly violent with it and cut away some of the plastic to try and make it that little bit bigger. Let me do that. Right, a suitable amount of violence has been applied to the case, and I have hacked away enough plastic to allow, work out how this went, the LED to show through a lot more than perhaps it was designed to, like that. So it sticks out quite a bit now. So that looks okay to me. And there's the button, on off. That is working fine. And it doesn't stick too far out either, which is good. Now, all of this is completely academic, unless the damn thing works. And I haven't even tried it yet, so this is you and I trying this together. Does this work? Let's try. Put the battery in. Whoops. If it will go. Yeah, it's a little bit springy, is that battery. I might have to adjust those springs in a minute. Let's just hold it in and press the button. Nothing! We have no life whatsoever. It's not working. One of the batteries dead. Who knows? Right, what have I missed? Got the resistor in there. Minus, plus, minus a plus. Wow. Houston, we have a problem. Yeah, all right, okay. I forgot to solder the other LED leg because I left that open to adjust it. So I'm an idiot. Fair enough, let's try again. So I've soldered it. Put the battery back in. Oh, which is extremely oh, there we go. We have life. On. Off. That's interesting. In is off. Out is on. Which is actually quite good when you think about it, because the button is almost flush with the case when it's off. So you're less likely to switch it on by accident. I don't know. And so I've got the switch the wrong way around. I don't know. I quite like it like that. That's working okay for me. Right, I'm just going to adjust the springs for this battery because it is desperately trying to pop out. So let's see if I can bend them up a bit. I'll just make them a little bit more likely to trap the battery a little bit more cleanly than it has been. Yes, I think that's a bit better. So let's, I think I need to bend the negative contact out a little bit. God knows how long this video is banging on for. It's only a little torch, for God's sake. I think I built the oscilloscope in less time than this. But there you go. Right, let's put that back in the case. Make sure that the LED is relatively straight, clean. Battery goes in nice and neatly now, and we pop on the case, and there it is. One little flashlight, quite bright. In fact, very bright. And for £1.26, and for a little bit of fun for an hour or so, I would say that was money well spent. Quite happy with that. Case doesn't clip together too well, I have to admit. If you drop this, the case is just going to explode. There's no two ways about it. But rather than it unclips, than shatters or breaks. But I think that's going to be quite a... Let's switch the lights off. Not making an awful lot of difference. We have got daylight outside still. But there you go, it's not bright, and I think it probably didn't make an awful lot of difference, to be honest, making this poke out. So that was probably not needed, thinking about it, because it is conical and it's got like a lens affair on the LED. So yeah, it probably didn't need that, but hey, it must still let out a little bit more light than otherwise it would have done, and I think that's pretty cool. There you go. So that's the FLA-1, I think, torch from Banggoodd. Nice little kit, bit of fun to spend an evening or an afternoon just popping that together. And like I say, it comes with different value resistors, 22 ohm, 47 ohm, and I'm guessing the 47 ohm would make it a bit dimmer, but will probably mean the battery lasts a bit longer. But we're not too worried about that. So there it is. Quite enjoyed making that kit. So let there be light, and there was light. And I'm going to say thanks very much for watching. Hope you enjoyed it. And a few more interesting kits coming from Banggoodd very soon, and I'll share those with you as well. In the meantime, a very happy Easter to you, and although you've probably had your Easter by now, the time this goes up, although I might put it up in a second, which is Easter Sunday. And either way, I hope you're having a good time, and thanks for joining me on this one. All the best until the next one. Cheers for now.